Hi guys, welcome back. In this video we're going to talk about a new method of solving quadratic equations. So we've looked at graphs, we've looked at the root method of solving and factoring. Here we're going to look at completing the square and why this method is useful to solve certain equations. So let's take a original problem here, x squared minus 10x plus 39 equals 0. What we might try to be tempted to do is factor this problem. What you're going to find though is that this trinomial, unlike the ones in our last video, cannot be factored. We'll see why in a little bit, but shortly and simply, you can try it on your own, use the box method, use the a times c method. No numbers, no whole numbers anyway, multiply to give 39 and add to give negative 10. So whenever that happens, we have to use a different method to try to solve our problems. Completing the square will allow us to do that. So I've listed the steps over here. Always will be the same. We're going to want to, number one, set variables to one side of our equation, move numbers over to the other. Okay, so in this case, x squared minus 10x, those are my variables. Opposite operations, move that negative 39 over towards the right. Variables one side, numbers on the other, that's step one. Step two, we're going to add by a number to both sides that allows us to factor on the left. Now what will that number be? It's always going to be b over 2a squared. This will always, doesn't matter what your problem is, it will always allow you to add by a number that you can then use to factor. So 39 was not a good number to try to factor with, but b over 2a squared will be. So don't forget, in this case, b is negative 10, a is 1. We talked about this in our last video. How do we identify a, b, and c? This is where we're going to start to use that. And we see that negative 10 over 2 is negative 5. And negative 5 times itself is a positive 25. Okay? We're going to come back to this number shortly, by the way. But a negative times negative is a positive. This is the number that we use to add to both sides. Whatever you do to one side, you have to do to the other. That was step 2. Step 3, combine like terms, number plus number or minus number. 25 minus 39 is negative 14. And to factor this side, which we can now do, we can break this down. What number multiplies to give 25 but adds to give negative 10? It's always going to be this number in parentheses here. Okay? X minus 5 squared equals negative 14. Think about it. Negative 5 times negative 5 is positive 25. Negative 5 plus negative 5 is negative 10. This is always the number that you're going to be using. You can use the box method to factor this, by the way, or the a times c method if you prefer, just to factor like we did in our last video. That's fine. The shortcut here, though, is that your number in parentheses is always going to be the number that ends up in step 3. And that's what this is, step 3. Okay. Final step, we need to solve our problem. To do that, we're going to do the same steps that we did to use the root method of solving, right? Opposite operations to isolate our variable. We're going to want to square root both sides. Opposite of a square is a square root. And when we square root both sides, don't forget a plus and minus symbol always shows up in front of your square root on the other side. Okay. X minus 5 now equals plus and minus. We can't really simplify the square root of 14. However, we do have a negative underneath that square root that we can take out. Don't forget that means I. I is the square root of negative 1. Whenever we have a square root, and that square root has a negative underneath, we have a complex solution. Or I should say pair of complex solutions. Remember, always a plus and minus symbol. You always have at least 2 complex solutions, never just 1. Finally, add 5 to both sides. 2 ways to write your answer. X equals 5 plus or minus I squared root of 14. One way. Another way that you can write your solution is that x equals 5 plus I square root of 14 and x equals 5 minus I square root of 14. You can break apart that plus and minus symbol if you want to. It helps you to see that there are 2 solutions. Okay? So that would be how you can solve problems by using completing the square. And again, a use for that is that if you can't factor your original problem, if you're going to end up with solutions that are not whole numbers, That's when this method is going to become important. That's one thing. Another reason that this would be important is because it helps us define what's called the vertex of our graph. Okay? At the end of step 3 in particular, that was when we had, I'll make a note of this to the side, when we had x minus 5 squared equals negative 14, we were one step away from actually finding what's called the vertex of our parabola. That's like the turning point, the place at which our graph turns around. This coordinate point can be easily found from vertex form. Now for this problem, where you would find that would be by adding 14 to both sides. We're going to move our numbers back over to where they started from. They started on the left. We're going to move them back over that direction. Okay. And we'll end up with x minus 5 squared plus 14. This is going to be our new function that allows us to, since it was rewritten, see where is our parabola going to be. Now where is it going to be? It's going to be at y coordinate of positive 14. That number off to the side will always be the y coordinate of your vertex. And the x coordinate will always be the number inside parentheses that turns all of this into 0. So what minus 5 equals 0? 5 minus 5 equals 0. This would be the vertex, the turning point of your parabola. And notice that this makes sense because we did not have any real solutions, right? Real solutions would cross the x-axis, but this says that we're going to turn around before we get there. So this is a way that we can rewrite our problem to always find the vertex. Even if we don't have a graph, we know 5, 14 will be our turning point, our vertex of our problem. Now, what I want to end with here is a scenario that tells us why the vertex might be important to find. So this is something that's the real world. Think of a diver who dives down y meters after x seconds into a pool, for example. So how would that look? And I'm given an equation to model this. How would that look? Well, a diver is going to go off a diving board, for example, and submerge, go deep down into the water, come back up for air, and high five his teammates because he did a good job diving or something like that. Okay, so that would be what the graph looks like. I would recommend, by the way, that you go ahead and graph this yourself to be able to make sure that this is something along the same lines of what you're seeing. Go to desmos.com/graphing and copy this equation into that calculator to see that this is the graph you should end up with. That's going to help you to visualize what this real world scenario looks like. Okay. Now, a couple questions. What does the x-axis represent in this scenario? It represents the top of the water. It represents the water line. Here is where the swimmer enters the water. Here is where he exits the water. Okay, so that's one question that's important to think about. Another, what's the vertex? Well, the vertex is going to be that turning point here. And from our original problem, we can actually see it's going to be at y coordinate -9, x coordinate, what minus 6 equals 0? 6 minus 6 equals 0. Your vertex is at 6, -9. You can see that just from your original equation. Double check it when you graph your problem itself. Finally, that vertex helps us to answer certain questions. Think about what's the lowest depth. How low does the diver go? He doesn't keep going down forever. He doesn't have scuba gear. Okay, he has to come back for air. The lowest depth that he goes is 9 feet below the water line. Right? He submerges -9 feet. If you want to put negative, that's fine as well. But 9 feet below the water line is what I'm looking for there. And how long does it take him to get there? 6 seconds. That's why the vertex is so important. It helps us to not only identify what our turning point is, but also to contextualize within a real-world scenario that this means it takes him 6 seconds to go 9 feet down and then come back up. That's his lowest depth. So that's one use for the vertex. Finally, I want to talk about, to end my video here, When will the swimmer enter versus exit the water? You'll notice that on the graph there were two real solutions, 2 points where that graph, that parabola, crossed the x-axis. I want you to find when does he enter versus when does he exit. Basically, I want you to complete this problem by completing this square. Use these steps. Okay. So how would you do that? Well, if he's crossing the x-axis, that water line, his depth has to be 0. He's not above, he's not below the water, he's right on the water along the x-axis. His depth will be 0. And all you need to do from here, solve by opposite operations, move all numbers over to the other side of your equation. Add by 9 to both sides. Divide by 3 to both sides, that's the opposite of multiplying, is to divide. Okay. That gives us 3 equals x minus 6 squared. Remember, square root both sides. When you do that, a plus and minus symbol should show up. Okay. And then you can add 6 to both sides at the very end here to get 2 real solutions. There's no I, these are real numbers, right? And the 2 solutions you get should be 6 plus or minus the square root of 3 equals x. Now, notice that I can write that a different way, right? One solution, 6 plus the square root of 3. Another solution, 6 minus the square root of 3. Which solution goes with him entering the water versus him exiting the water? This is why I want you to stop the video to maybe think about first before you answer it, or look at the solution. But if we look back to our graph, okay, we remember the vertex was at 6, negative 9. This is where he entered the water, this is where he exited the water. 6 minus the square root of 3, that'll be where he entered the water. And then 6 plus the square root of 3, heading away from 0. This will be where he resurfaced or exited the water. And that is how completing the square can help you to find not only real solutions, but also what those mean in a real-world context. So in our next video, I will talk about the quadratic formula, and that will actually wrap up this unit, and you'll be ready for any assessment that comes after that.